Yep, what is it? Yeah, so it's B2A, F equals G M1 M2 over R squared. So F is the gravitational, gravitational attractive force. The G is a universal constant. M1 is mass 1 and M2 is mass 2, and R is the distance, distance between the center of masses. You don't need to write that down. I really hope you know that one. So let's go on to the B part. B part 1. The planet Mars can be considered to move around the Sun in a circle of radius 2.28 times 10 to the 8 kilometers. The mass of the Sun is 1.989 times 10 to the 30 kilograms. What's the velocity? Right, so I think we want to use a mixture of F equals MA and F equals GMM over R squared. And also maybe we need to use F equals MV squared over R. No, I'm just giving myself ideas, yeah. So I think maybe the second and third one, if I put these together, I can get GMM over R squared equals MV squared over R. They're looking for speed. That cancels, and then square root. Yeah, there we go. So the V is equal to the square root of GM over R. Easy peasy, because now we know the G, the M, and the R. That's a big M, by the way, the mass of the Sun. I'll just double check. 6.67 times 10 to the minus 11 times 1.989 times 10 to the power of 30 over the radius, which is 2.28 times 10 to the 8 times kilo 10 to the 3. What did you get, Tekken?
I didn't put that 2.
It's okay, we all make mistakes. 24122 meters per second, which is correct. Okay, or if you want, you could say that's 24.1 kilometers per second. Okay, B part 2 now. What is the time? Well, we have T equals 2 pi over omega. Do we know the omega? Yeah, well we could say you have F equals mv squared over R, and also F equals m omega squared R. Yes? To find the omega, to find the T. So I can put these together and get mv squared over R equals m omega squared R. So that means the omega, that cancels, that comes down there. Oh, what am I doing? It's just V over R. That's a formula, I forgot. It's a formula which I forgot. Omega is V over R, because the formula is V equals omega R. Well anyways, I just proved the formula. Right, so we can put that back in here, and we get T is 2 pi over V over R, so that would be 2 pi R over V, So T is, okay, 2 pi or over V, which we have. Now this answer is in seconds, so divide by 3,600 to make hours, and divide by 24 to make days. So I got 687.4 days. Okay, 3. The Martian moon Phobos takes 7 hours and 39.2 minutes to complete one orbit. Okay, so here's the moon going around Mars. The time is 7 hours and 39.2 minutes. The radius of this orbit is 9400 kilometers. Calculate the mass of Mars. Now, you can use Kepler's law here if you remember it. If you remember it. Do you remember it? T squared.
4 pi squared.
T squared equals
4 pi squared r cubed over
GM. Now, this is not in the formula book. So if you don't remember it, you're going to have to prove it. Now, the proof is not too difficult, but it takes time. And when I look at the number of marks, it's only 4 marks. But the proof was in class, yeah?
If any formula is not in the book,
you can use it.
No, I know we can.
Yeah.
Do we have to prove it first?
No, if you remember it.
Okay.
Yeah, I'm just saying, if you don't remember it, you have to reprove it.
Okay.
Yeah. What are we looking for here? I forget. The mass. So the mass equals 4 pi squared or cubed over G T squared. Okay. 4 pi squared times 9400 cubed the time. Rats, we better convert that time into seconds. No, I need to convert the time. 39.2 minutes. There's 60 seconds in a minute. So the time in seconds is 27,552 seconds. Okay, now I can calculate it. 4 pi squared and the radius cubed over 6.67 times 10 to the minus 11, and then the time squared, syntax error, I got 6.48 times 10 to the 23 kilograms, which is correct. Ooh, yeah, indeed. Right. Now, part 4 is what is the field strength. So do you remember the formula for the field strength? That's for electric. It's G M over R squared, isn't it? Is it this one? Yeah. Do we know the G and the M and the R squared? So the G we know for sure, it's a constant. The mass, do we know the mass of Mars?
Yes.
Yeah, that was the previous one we just had to work out, wasn't it? And do we know the radius of Mars? It's 3,000 It says it in the question. It is 3396 kilometers. So it's quite big. Maybe we'll put it in mega. Sorry, I wrote E like an idiot. It's not E. What letter do we use for gravity? G. Oh, come on, pen. Isn't that the formula, or is there a square? I don't know. I'm not sure.
There's a square.
There is a square, is there?
Yeah.
Are you sure? Is it GM over?
But
There is a square. Okay.
let's do it till find out.
That's okay. It is a square. All right. So I get an answer of 3.75 newtons per kilogram, which is correct. Okay. C part 1. Great. A spacecraft attempting to land on Mars is in orbit. It releases a probe 100 meters above the surface, so it falls vertical. What is the velocity on impact? For babies. Because this is just a UVATS problem. What's the U? It's 0. The V is what we want. The A, what's the A? Which is what? Minus 3.75. T we don't know, and S is minus 100. It's fallen from the sky down to the surface of Mars. And what do we want? The V. V equals U plus AT. No. V squared equals U squared plus 2AS. So V will be the square root of 2 times 3.75 times 100. .4 meters per second, which is correct. And lastly here, part 2, the probe hits the sand. So what happens here is the probe is traveling down with a speed of 27.4 meters per second, but then of course it stops a distance of 0.265 meters into the ground. The mass is 5.32 kilograms. And are we given the time? No. So I'm thinking there's two formulas here you could use. You can use the formula that impulse is the change in momentum, and the other one another formula for impulse is force multiplied by time. Could we use that one? Or we don't know the time. No, we're looking for the force. We don't know the time. Do you know what? I'll just calculate the acceleration. So we have UVATS. Okay. U is minus 27.4. V is 0. A we don't know. T we don't know. S is minus 0.265. And if I go with V squared equals U squared plus 2AS, the V is 0. So we can get A equals minus U squared over 2S. So I can get my A as minus U squared over 2S. Right, so the A is large, 1417 meters per second squared, and that's upwards.
And then you just multiply the M by the G. We know to G at the moment.
No, because but that's the downward weight. What's happening here is there's an upward force from the earth, from the sand, slowing it down. Yeah. So, okay, well, now we have the A, we can do F equals NA. So, this upward force acting on it is 7536 newtons. It is, well, the answer is 752, so it's fine.
7520.
7520, yeah. Now, I feel like this question's English could have been better, because if I was doing this, I would have looked at it this way. For me, I would still continue, because that is the total net force acting up, yes? But how many forces are acting on this ball? There's actually two forces. One, you said kj, which is the weight, and one going up, which is from the earth, or what they call the retarding force, which I'll just write as or. So really, if I want this, I need to say or minus w equals 7536. So or is 7536 plus w, which is mg. Now what's the m here? 5.32, isn't it? But what's the g? Yeah, which is what? It's not 9.81, it's 3.75. So really, for me, the proper answer here would be 7556 newtons. Because the question says, what is the average retarding force? I really wish the question used the word net. So if the question used the word net, it would mean this one. This one is the net, the total. But they didn't, which means I feel like this is also an acceptable way to continue. However, the question is only 3 marks, so I don't know. It's a bit annoying. Right, let's have a look. We can get a little bit, maybe. I don't know. Yeah? Questions? No? Do you know what? I might do question 4 really quickly, because it just requires Excel.